hip hop bot. Is it a bot?
From the past messages with me and Charlie, she told me to type lo-fi in the meeting room, but it doesn't work anymore. That was like, can't remember, like 2 years ago, 2022. Yeah.
We'll get it for next time, guys. No worries. Okay. I think this is a good amount of people in here already, so we can just go ahead and get started. Thank you all for joining the first Project Spotlight. I'm super excited to get started on this. The way that it works is every month we'll have one Project Spotlight, and there will be a certain theme. For today's theme, it's identity, a huge topic in the space, and we have projects such as TLSNotary, Anon Aadhaar, and Semaphore that will be giving demos. After their demo or presentation, there will be a 3-minute Q&A if you have any questions to ask briefly. And then after we're done with all of the demos, presentations, we will move on to an open discussion. And that is where anyone in this room can contribute to the conversation of identity. So if you work on identity currently or have any questions or thoughts or something to contribute to the conversation, definitely feel free to unmute yourself and contribute. So without further ado, the first project that we'll be presenting today is TLSNotary, and we have Hendrik, who's representing them. So Hendrik, you have the floor. Share your screen and take it from there.
Hello, everybody. Thanks for the introduction. So I'm Hendrik, and I represented indeed the TLSNotary team. So I'll do a quick recap of what TLSNotary is. I see some team members here where this will be very familiar. So conceptually, TLSNotary solves a really simple problem. So it's how to query web servers and share that data with another party in a secure and privacy-preserving way. So TLSNotary is built on top of TLS. So that's the S in HTTPS that we all know. So that's a very good protocol to get data from a website, and TLS ensures that the data is authentic. Nobody changed anything to it, and nobody can listen in. So privacy is guaranteed. But unfortunately, it also has a downside. The data is not portable because TLS uses symmetric encryption. And that's the solution or the challenge that TLS solves, is how you can get portability. And TLSNotary does it in such a way that your privacy is protected. You don't need external trust, and there's also no changes required to the original website. And so the result of all this is that all data on the internet becomes composable, especially the private data. How we do this is too much detail for this 10-minute demo. So, but there's lots of crypto magic going on in the background with multi-party computation. The end result is that when Alice wants to share private data that's on the website with Bob, she can use TLSNotary without changes to the website. Alice has full control over what exactly she shares with Bob, and also Bob gets cryptographic guarantees that nobody can cheat. Of course, it also has a cost, so there's a lot more bandwidth between Alice and Bob than just sharing the data. But we're always pushing that limit with our talented team. So I said privacy. How exactly does that work? So TLSNotary has two features there. On one side, we have redaction. So for example, here there's a HTTP request where Alice can redact some stuff that's not shared. And then in future versions, it will be easy to add ZK proofs there to hide or disclose information. So it's all open source, but let's skip this and go straight to the demo. So today I will demo the advances we made with the browser extension. So I'm running a local build here. And so when I open it, so this was all here, but what's new is that we now have a plugin system. So you can add new plugins here to access certain data sources. For example, I have a Twitter messages plugin here. And when you run this plugin, it shows you some steps. So first it said you have to visit the Twitter website, navigate to your DMs. And what this plugin will do is create a notarization proof of this GM message I have here. While this notarization is happening, we'll already switch to VS Code, where we have code for adding an extra step. So next we will do a Twitter profile proof. So that could be like for the identity proof, where you could use that you have access to a Twitter profile. So building this plugin is as simple as doing an npm build. And then in TLSNotary, we can add this plugin with the WebAssembly. The user then has control, can decide whether to allow this plugin or not with some overview, and then this plugin is added here. And so in the meantime, we have our proof here. So you see the redacted information, also the remove, and there somewhere in here there should be this GM message, which then can be shared with Bob. And so to prove our Twitter profile, it's very similar. Here we're already on the Twitter website, so it starts immediately. And I can go check the history here to see an older version of this proof, where you can see that this is the TLSNotary Twitter account. So I hope I stayed within my 10 minutes. So I can dive a lot deeper if there's any questions on how to create proofs. One important thing is, so I've only shown like how to get the data. Of course, if you build an application, you will also want to query these proofs. For now, this is documented in the TLSN extension wiki, where we then also explain how you can connect to the extension from a web page and then query the proofs to implement the actual useful stuff in your application. Questions?
I have a
Was I too
question.
fast? Yeah.
No, I think that was perfect. You're right on time. Question is, have you guys like explored using signatures at all?
What do you mean exactly with signatures?
I guess because right now you have to rely on like a notary, right? So there's an element of trust within TLSNotary.
Yeah.
So I was wondering if you guys, if there's a world in which you use signatures in your protocol or could.
Yeah, of course. But so indeed, in the browser extension, we work with a separate notary, which I didn't introduce in this schedule here. So if it's also possible to use TLSNotary directly between Bob and Alice, and then there's no external trust required. But that option is not available in the extension yet. It is available if you use the native Rust library. And then also, the TLSNotary is still work in progress. So the format of the proofs that we currently have, well, proof, it's more an attestation, will also still change. So currently it's a very naive JSON dump, and we will definitely improve that in the future. And that data is indeed signed by the notary. So when somebody wants to verify a proof, he will check the notary signature and also, of course, the signature of the original website or the certificate. Sorry.
Awesome, thank you.
But so it's all open source. You can go to the TLSNotary website, find all information there. We also have a separate Discord from the PSE one. So you can also find us there with more questions.
Okay. Well, are there any more questions for TLSNotary? We have 3 more minutes for their Q&A.
Okay. You can also meet us in person. So the next events we have on our agenda are the blockchain in TUM in Munich. I think that's half of September. And then most of the TLSNotary team will also attend DEF CON in Southeast Asia in November.
Hendrik, could you share are there any like exciting upcoming releases? Are there like soon or on the horizon? Like anything that you can share with us? Or
Yeah,
features?
so we're working on features to verify TLSNotary attestations on chain. So that will be a nice one. And then we're also working on improving the algorithm to get huge performance improvements while still guaranteeing that everything is saved. But this will be like a continuous process. But we're making good progress there. So that's the core protocol. Also for the browser extension, so what we currently have is still like the extended prototype, and we're cleaning up the code now to make it more production ready. And then next year we plan to start audits of our code so that we get ready to be used really in production.
Okay. Well, awesome.
And then what also might be a fun thing to do to learn more about TLSNotary is have a look at our use cases. So on our landing page, we now have, thanks to our design team, some use cases here that allow you to dig deeper and get to know how TLSNotary is used in the wild.
No, not yet.
Okay. Rowdy, do you have a question, or I think your mic may be... Okay.
Sorry, apologies.
No worries at all. Well, if that's all, I think we've reached time. Thank you so much, Hendrik, for your amazing presentation. It was amazing.
Thank you.
Yeah, and if you guys think of any questions for TLSNotary afterwards, you can just ask during the open discussion. Okay, So next we have Semaphore. We have Cedar who will be presenting for Semaphore. So you have the stage, Cedar.
Hey, thank you so much. Yeah, thank you so much for this event, first of all. I'm Cedar, and I work with the PSC team. And I'm a software engineer, and I have been working on Semaphore and mainly on Semaphore and ZKK. So maybe I can make like a short introduction of Semaphore. This is our website. So Semaphore is a protocol you can use, users can use to prove that they are part of a group, and they can generate a proof. Like they can prove that you are part of the group, and they can send a message, an anonymous message, without revealing their original identity. So sorry, because I don't have any presentation, so I will use the changelog of our release. We just released Semaphore like 2 hours ago, like the stable version. So I will probably miss a lot of details, so I will try to be super quick. But if you have any questions like about any details, feel free to ask them later. TLDR, like the main changes for Semaphore v4 are two. First, it replaces the old incremental Merkle tree with the optimized lean incremental Merkle tree for managing groups. And second, it updates the identity schema. So we are not using Poseidon anymore, but we are using EDDSA. So let's go into the main updates of the new data structure are related to zero hashes and dynamic depth. So we are basically not using zero hashes anymore. The first version of the incremental Merkle tree, the one we are using with Semaphore v3, was using zero hashes, which are like hashes that we use to calculate the hash of the parent node for each level. These can help, I think. And with the new version, we are not basically, we don't need anymore the zero hash, because for each level, take a look at the tree on the right here. Even if there is one child node, the left one, we are basically using the same node to, we are not calculating the hash for the parent node, but we are copying the value of the child node. The other important change for the incremental Merkle tree is related to the depth. In the first version of the data structure, the depth was static, meaning that every time you need to create a Merkle tree, you have to think about the right depth at the beginning, and you have to specify that. And there is also like a maximum number of leaves. So if you choose, let's say that at 10, you will have a maximum number of leaves, which is equal to 1024. With the new data structure, the depth is dynamic, and the tree depth is updated as the leaves are inserted, and the number of hashes is like to be computed, it grows as the tree grows. So as you can see here in the tree on the left, the depth is 2. And before inserting a4, after inserting a4, the depth is 3. So that like the depth of the tree grows. And the other important update related to the new version is the new identity schema. We are not using Poseidon anymore. In Semaphore v3, the identity commitment, which is like the public value of Semaphore, the Semaphore identity was the Poseidon hash of two secret values, basically, the tractor and the nullifier. In the new version, the identity commitment is the Poseidon hash of the public key of the EVDSA public key. This was necessary because we have noticed that in many use cases, developers needed something more than Poseidon for signing messages, for example, or for verifying those signatures in other zero-knowledge proofs. It had some constraints to the circuit, but not so many. So the times for generating and verifying the proof are pretty much the same. I would like to show you some benchmarks. This for Solidity is pretty interesting. So in the first table, you can see different groups with different leaves. This is the previous incremental Merkle tree. We are using one in Semaphore v3. And creating a group with 1,000 members costs something like $8,000. This is the mainnet, of course, and this is like it was the current price of yesterday. Whereas with the new insert function of the new incremental Merkle tree, the incremental Merkle tree, the cost is much less, is $4,400. And additionally, we also implemented a new function, the insert many function, to insert multiple members. And that further reduces the costs. And in order to create a group with 1,024 members, this is wrong. You need like less than $1,000 basically. So for example, if you have an off-chain group with 1,000 members and you want to transfer it on-chain to the mainnet, considering the costs above, with V4 you save basically $7,000. Of course, the JavaScript implementation as well has improved. Inserting new leaves is much faster. You can take a look at the table here, and we also implemented an insert many function in the JavaScript implementation as well. So another section I wanted to show you is related to developer experience. So we have worked on some improvements in terms of performance, but also developer experience. These are just the main, the core JavaScript libraries. For the identity library, it doesn't change so much. You just need to pass a value. That value was the secret in the Semaphore v3 version, but in the new version is the EDSA private key, but it's pretty much the same. The group library is a little bit different because you don't need to pass any parameter anymore. You don't need any ID, which was used to calculate the zero hashes. And you don't need to pass any depth anymore because it's not static, it's dynamic. What changed more is the proof package, and the function to generate proofs takes the same first two parameters, the identity and the group, but the external nullifier is now in another position. So they are inverted, the external nullifier and the signal. And they have different names. So the external nullifier is now called scope, and the signal is now called message. We decided to change them for clarity. And you don't need to pass any artifacts anymore. It's optional, of course you can do it, but both on Node.js and browsers, you can omit that parameter because they are downloaded automatically. The verify proof function as well needs only one parameter. It doesn't need the depth because, as I said before, it's dynamic and it's part of the proof. And that's it. I think I don't have so much time.
Does anyone have any questions for Semaphore? Okay. So
Right.
Cedar, go ahead.
I have a question. Yeah, I have a question. Sorry. Have you, Cedar, have you benchmarked or is Semaphore supported on any L2s? I think the benchmarks you were looking at was like mainnet, base layer Ethereum, but I'm curious about like L2 support.
No, we don't have these benchmarks yet, but yeah, it would be like to have them.
Okay, so there,
we will
so
have yeah, sorry.
Oh, no, I was just asking. So there are Semaphore. You can deploy Semaphore or use Semaphore on L2s. Or I guess which L2s or which ones does Semaphore is can you deploy Semaphore on?
Semaphore is already deployed on let's see on 4 networks now. Sepolia, Arbitrum, Sepolia, Optimus, Sepolia, and Matic so the new testnet for Polygon. But we are going to deploy it in as many networks as possible. So yeah, possibly like the main ones, maybe 10 or 20. That's part of our milestones in our roadmap.
Awesome. Thank you.
So one question I have is like where like what projects or where have you seen the biggest use cases for Semaphore currently?
I think Zupass is the like biggest, and of course WorldCoin as well. But WorldCoin is not using all the libraries, only the contracts, only some libraries. Yeah, after WorldCoin, I would say Zupass, which is one of those use cases that led us to implementing the EDDSA identity schema. And yeah, if you want like a list of projects, you can even go to the website and you will find a nice dashboard to navigate them based on categories. Yeah, maybe another update is that we are going to publish a paper for the new data structure, the linear incremental Merkle tree. So Vivian is working on that, and we probably publish it next week or in 2 weeks. There will be more details. So I know that this is quite complicated, and 10 minutes are not enough to explain everything.
Okay, awesome. Thank you so much, Cedar. Really excited for the Semaphore project and to see where it goes. This is like one of PSE's biggest projects. So yeah, thank you so much for presenting that.
Thank you.
Yeah, of course.
Mhm.
Okay, so last project that we have for today before our open discussion is Anon Aadhaar, and we have Giannis who is going to be giving a presentation on Anon Aadhaar. So Giannis, you have the floor next.
Yes. Hi everybody. Can you see my screen?
Yes.
All right. Perfect. Yes. Thank you. Thank you everybody for being here and to hear about all this amazing identity project. I myself am Yanis. I'm PSC member. I'm a software engineer and currently contributing to Anon Aadhaar, and alongside the Anon Aadhaar team with Ridam, Salil, and Andy. So what is Anon Aadhaar? Anon Aadhaar is a zero knowledge protocol that allows Indian citizens to prove their identity through their Aadhaar card. So I'm just going to briefly introduce what is the problem we are currently solving. So the status of the current solution right now, like in the digital space, to when it comes to prove your identity, it's quite bad. Like when you have to do KYC, you have to reveal like your full ID card, all the information about yourself. Sometimes take picture about yourself and send it to a server that then like will assess if you're a human or not. And yeah, also like on some identity systems like Aadhaar, for example, you can have like it's prone to like a lot of hacks and privacy leaks. So you have like a bunch of Aadhaar that are like available in the dark web, for example, which is quite bad. And also like when it comes to like on-chain use cases, and you want to prove like that you are human, or you want to add like a cyber resistance layer to your contract. There is no perfect solution to do that today. So yeah, just wanted like to, here the goal is not to compare, but like more like to give just a mapping about where we are. So one approach would be like biometrics when it comes to like prove your identity on chain, which is like the approach that uses WorldCoin, for example. You have aggregation, which is used by Gitcoin Passport. So if you were able like to prove that you have some activities on platforms like GitHub, Discord, or Twitter, then I can compute a score and assess like how much I think you're human. And then, so the last approach that we are working on is actually leveraging the signatures that you can find like on some identity documents and use ZK to generate a proof of this signature. So here is just a little scheme to explain a bit like what is the current architecture in the digital identity space. So it's the same architecture that uses Aadhaar, for example. So the government basically they have like a private key. They will compute. They will take your identity with which can be represented in a blob of data, like your name, your date of birth, the city where you're born or you live. Then they're going to hash it. They're going to sign it with their private key, and then they are going to from this process there are going to be like two things that would be that are going to be like outputted is the signature and the message. So then the signature and this message are like inserted like in some documents through an NFC chip or a QR code. And then when Bob like wants to verify your document, he needs to have access to the signature, the message, and the public key. The public key that you can fetch from the government website. And then Bob is able to verify the signature. But the issue here is that Bob have access to now your the message, which actually is your identity, and the signature. So yeah, just to illustrate, so here is how it works like on Aadhaar. So you have like two ways to get the QR code, which represent like signed data, and the signature. So here is a PDF that you can request as an Aadhaar citizen, like as an Indian citizen. You can request like your Aadhaar as a PDF format, and you have like the QR code stored inside of this PDF. Or you can use the Aadhaar app. This is an official Aadhaar application, and you can redeem like at any moment like a freshly signed QR code through this application. So I'm going to be brief here because I guess that everybody like knows a bit about ZK, but just to introduce that we are using ZK-SNARK to have like the same signature verification process I showed before, but like just ZK-SNARK like give us the ability to have private inputs. So now the verification process is actually hiding the signature and the message from the verifier. So the verifier would just receive like a snark proof that states that a signature verification of a document were done properly with the public key. So then Bob can check the public key, check that this is the same public key that was like published on the government.com, and he's now able to assess if you're like a human. So here is sorry, like the schema can be a bit overwhelming, but the goal here is not to go into the detail, just to explain a bit what is happening into Snarkland. So basically, like the QR code is signed with a signature algorithm, which is called RSA. And in RSA, you're going to sign the SHA-256 hash of your identity, your name, your date of birth, etc. And so what we are able to do now in Snarkland is that we are able to verify the signature to authenticate the data. And then once we authenticate the data, we can extract some fields of the data that can or can't be revealed. So for example, we are computing a nullifier, which is going to be like your new unique identifier in front of everybody with your new anon identity. We are currently using the timestamp as a proxy that you have access to some freshly signed data. And we are also achieving selective disclosure on 4 fields. So you can prove, for example, that you're above 18. You can prove your gender. You can prove the state where you live, and you can also prove your PIN code. So just a quick demo. So here is our boilerplate app. So here I already connected my wallet, for example, and I'm going to generate a proof of my identity. So here I'm just using test data, but the logic remains the same. So here, like the prover will show you like what you're gonna reveal. In that case, we don't need to reveal anything because the use case is like we are gonna vote like on a smart contract, and we want to ensure that it's one person, one vote, right? We are committing to the address to avoid front running on chain. So by committing to the message.sender where with the same message.sender with whom I'm going to send the vote, I can prevent like from front running. So actually the process is taking around 26 seconds on a MacBook Pro M1 Pro. And yeah, so, but we are actually using Circumgro 16 to compute the proof. So we can ensure like fast verifying time of the proof and cheap cost of verifying a proof on chain. Yes, so here we are. We generated our proof, and then we can vote. So I like this app, so I'm gonna put 5. I'm not sure like the going. Yeah, it's not working because I already voted, but yeah. So here it is. How you can like just quickly like add like this privacy layer to your app. So we have a full SDK. It takes like bit less than 5 minutes to integrate the SDK. And you can add like a new privacy layer to your applications.
Awesome. Thank you so much, Giannis, for your presentation. This is a really cool project. One question I have for you actually is like, what has the adoption in India looked like of Anon Aadhaar? Like, are there new apps that are coming from this, or people that are using it, and yeah, just go a little bit more into that.
Yeah, so I guess it's like where we are going to put a lot of effort on is like just show to the Indian community actually the tool and how they can use it. We have now like a production ready version since a month and a half, 2 months, and we securize the protocol through a public setup ceremony. And yeah, and so actually one cool use case that we developed is that you can now redeem. I can put the link in the chat if there is some Indian folks in the room. But you can now redeem like a discounted ticket for a DEF CON, for example, because DEF CON wanted to incentivize people from the area to go to DEF CON. So they wanted to have targeted discount, but without doxing people. So you can like generate just an anonymous proof of your Indian identity and redeem a voucher.
Okay, are there any questions for Giannis? Or any follow-ups on Anon Aadhaar at all?
One question here.
Go ahead.
So, is this also useful for non-Indians?
Yes, sure. So this primitive about like snarkifying the verification of a signature is you can apply it to any identity document that has a signature in it. So there is another team at PSC which is called the Proof of Passport that is applying like it to passports. We did also like during the ETC PSC Hacker House some research on the new European identity card, which has also like a chip with signed data inside of it. We know also that there are other digital identity programs out in the world that has like a representation of your identity through signed data. So as soon as you have like a document or at least like a way to have from a trusted issuer, which is in this case the government, like a signature of your identity, then you're good to go and you can replicate it to your identity. Yes.
Yeah, proof of passport is another cool project that very much is very similar to Anon Aadhaar as well. Yeah, there's a couple more identity projects that are like grantees as well. We'll have to do like an identity day part 2 sometime and get some of those projects as well.
Yeah, there is also Mina Wallet for the Japanese ID card. We also are maybe we are gonna support a team for Europe identity card. There is also like some research that done on like the Costa Rican identity card. So yeah, the goal is to have like to spread all the all around the world to have like all the signatures certified.
Amazing. Amazing. Okay. Well, are there any last questions before we move on to our open discussion for these last 15 minutes? If not, then thank you so much, Giannis, for presenting Anon Aadhaar. And now we can move on into our open discussion. And this is a chance for us to just talk with each other about the topic of identity. And if anyone has any comments, concerns, questions, or anything about identity, just feel free to voice your opinions. I guess one question for the presenters is like right now we have these 3 amazing identity projects. Have you guys like considered potentially how you can work together to maybe come up with like a identity system?
Um, I know. Sorry, I know on our side maybe Salil can speak more about it than me. But we did like try for example like some semaphore integration. So when it comes to like generate a new proof of identity from like a real identity, sometimes like one hard problem is that you want to obfuscate it. So you want to have like another privacy layer which resolve always the same unique identifier. So one way, for example, to hide any action from the issuer of the signature was that generating a snap proof that you have like a signed document, and then like using this snap proof to be added like to a semaphore group, and then you can use this new semaphore identity, which is linked to the verified Aadhaar group to use it. Also, like I think TLSNotary could be really interesting, like when it comes to like when countries that don't have like actually a signed document, but have like I don't know like a trusted API. So then you can replicate the process, but through like a TLS proof from the official server.
Yeah, indeed. So systems like Elster in Germany, or I think in the US, ID.me, I think, are like good sources there. And so we also are looking into setting up a project with Bandada, which is also using Semaphore under the hood.
Do you want to talk a little bit more, just a little more detail on that?
It's still early days, so
Okay.
but the idea is there indeed to use TLSNotary as a data source to check whether you can join an anonymous group or not.
I think TLSNotary was also used in ZK um, right? I think with Revolut.
Yeah, but so that was for proving transactions, not proving identity. But of course, any data source could be used with TLSNotary. So all very exciting use cases.
Well, another question for everyone here too is like, I guess, what are the biggest challenges that we face when it comes to like identity right now?
I guess like the main issue is standards. So because there are like some working groups that works like since several years, trying to have like a standard when it comes to like manage identity in the digital space, have like privacy and working on selective disclosure and have like the right to have anonymity in the digital space, but still like have like a bunch of credential linked to your identity. So I guess it's gonna become yeah way more used in the future. I think there's just an issue about standards right now. Like um, we need to find one main standard where everybody can build on top of. But I guess that the W3C standards might become like maybe the way to go in the future.
Sorry, what system did you say? W what?
Yeah, I'm gonna send the link in the chat, but basically it's like sorry, I don't want to say something wrong, but I think it's like a working group linked to ETF, and they are basically like working on a protocol, or it's more like a standard um, for DID, like decentralized identity system. Um, and I'm going to send some links if you want to like dig deeper into these standards.
Very cool. I have to look into that. I didn't know this existed. Thank you for sharing, Jonas. So, also curious, like, have you guys had any like regulatory issues when building out your projects at all?
Um, so sorry, I'm gonna answer. No regulatory issues, but I guess that we are too small now to have any request. But of course, I guess the goal is like more work with in the hands with governments and like show them like the primitive. And yeah, I know that for example in the EU, like we saw that in the April Parliament discussions, they spoke about ZK as a tool for privacy preserving use of digital identity in the digital space.
Really, is there like a link or something where I can go check that out?
Yeah, sure. Let me send it to you.
Really cool.
Also, no regulatory issues for TLSNotary. Of course, people could use this for illegal activities, but that's not what we build it for. So please, if you use TLSNotary, always respect the end users agreement of the website you're contacting.
Okay. Let me see. Does anyone have any other, like, I guess, inputs to the conversation or questions or comments on identity, if what you've been thinking about? Would love to hear from anyone here. There's a lot of bright minds in the space right now. I think this EU thing is really cool, though, to see that like governments are now starting to talk about ZK. It shows that the technology is actually useful and something that will be very important in the future. So I'm excited to have conversations like this and to learn more about these primitives because I think they're just going to be so important in the future. So good for us to learn about these things now and build on them and make the infrastructure as solid as we can make it while it's early. And also like maybe finding more ways in which we can communicate with these governments, especially since we're the ones that are building out these cryptographic tools. So I think we know the most when it comes to like ZK and this stuff. So um, yeah, I think it's really important that we engage with um, these governments as well, especially in the coming years. Okay, I think we have some people typing. Um, okay, I think he can hear us now. There's a question in the chat. Vika says, "Hi guys, how can we standardize circuits for cryptography primitives so they can be used by everyone?"
I think maybe Stedor, like, isn't it like the goal of ZK-Kit?
Yeah, not really. I think it's a goal for Semaphore more than ZKKit. But yeah, I mean, defining what a standard is quite tricky. But to answer that question, I think we need to make like a standard or a protocol very popular in order to make it a de facto standard. Or maybe we can have an institution, like an international institution, that can make it a standard. I think there are two ways. So one is to making like to make the protocol really popular and common, and the other one is through a like broad consensus from government and institutions.
Okay, did that answer your question, Vika, or did you have like any follow-ups to that? Amazing.
So maybe a standard that it's worth mentioning here is PCD, which is like what Zupas used last year. I feel like that's a great example, and yeah, I mean, we should try to push it, I guess. I can send a link.
Yes, yeah, just Anon Aadhaar is also using the PCD standard for managing the prover and the verifier.
I don't know why he still can't hear. I'm sorry about that. Maybe you can. We are recording this whole thing, so and I'll post it on YouTube, so you should be able to go back and listen to it. Yeah, sorry about that. Okay, well, I think we are coming up on the hour. Want to say thank you to our amazing speakers and presenters. Learned a lot today about your projects and the topic of identity. We're definitely going to have an Identity Day part 2, featuring some more projects within PSC, because I think there's a lot of interesting projects in PSC, grantees as well. So stay tuned for that. I'll be posting the YouTube video later today, and I'll also be putting out our next project spotlight sometime, maybe next week or so. So stay up to date with that. Thank you all for joining. It's been really amazing, and we can't wait to see you at the next project spotlight. Bye for now, guys.
Thanks, everyone. Bye.
Thanks. Bye bye.
Thank you. Bye.